Good morning, students. In the previous class, we have derived the equation v is equal to u plus at by graphical representation, and today we'll go for the second equation of kinematics. So in the first equation of kinematics, we proved that v is equal to u plus at. One more information I should give you, that it is v is equal to u plus at, that is equation v is equal to u plus at. This particular equation has another name, and this equation is also known as velocity time equation. This thing you please write down that this equation is also known as velocity time equation, that we proved in the previous class. V is equal to u plus at. Today we are going to prove the second equation, that is s is equal to ut plus half at square. You kindly write down that second equation, that is s is equal to ut plus half at square. S is equal to ut plus half at square. This equation has also another name. This equation is known as position time equation. Remember, this is position time equation. So what I found, that's the previous one was your velocity time equation, that as we have proved. I hope you have understood it. You have gone to practice. Okay, if you don't practice these things, it is very it will be very difficult for you to get the things rightly. Okay, so you should to practice more and more all these things, and clearing the concept is again more important than by hearting. If you go for by hearting these things, so it will be a very funny thing in physics. Okay, it is never a matter of fighting, and it is not jokes you are playing with us, or you are playing with your life. Okay, so this is s is equal to ut plus half at square. This is position time graph. These are initial stage of physics learning. If you want to make this initial stage very strong, no, your root will be very strong. Then in upcoming time it will be very easier for you. But once you fail in this period to clear your concept, basic concept clear, then you know what disaster will come to your physics life. Okay, so don't get panic. We are with you. Any problem, just frank to tell me. That's the important thing. So this is s is equal to ut plus half at square. We are going to prove it. Diagram will be similar as we draw for the first equation. If I take a diagram again, suppose this is the diagram we taken as in the previous case. Nothing change going to happen. Remember one point I mentioned, that we are going to derive all this equation for a body that is in uniform acceleration. The body should be in uniform acceleration, and acceleration we are not taking zero, we are taking initial velocity, we are not taking zero, we are taking initial velocity, some amount of initial velocity we are considering for the body. So in this case, this will be your time, that is t, and this will be your velocity, this is suppose 0. So if I take some amount of that, if I consider that the initial velocity of the body is not 0, that means we are considering this body is starting from here, and the graph, as you know, this will be like that. Is that clear? Suppose this is point A and this point is B. Okay, that is velocity. Initial velocity has started from A and ended at point B. So I will join a line here so that I can get the final velocity. So this is O, and I will again join this line so that I can get the time covered, and this is also be joined to make the thing complement. Is that clear to all of you? So let us give the name of this point as you gave. This is A, B, this is C, this is D, this point is E. OA, this OA will be your initial velocity. Okay, this OA will be your initial velocity. This OE is going to be your final velocity, and the rest are as well as we have discussed in the previous diagram. So we have some assumption, and again we can write that OE and BC are same, so we'll write OE is equal to BC is equal to final velocity, Is that clear? OE is equal to BC is equal to final velocity. Next, you will have OA is equal to CD is equal to, this is, you can write again, this is O not A, this is OE. OA is equal to OA is equal to CD, we can write, and this is going to be initial velocity. Let's be very, sincere in order to this assumption. This is OE and BC are same, these are final velocity. OA and CD are going to be your initial velocity. So this OC and AD are going to also be equal. You can write OC is equal to AD. Okay, this OC is going to be equal to AD, and these are going to be your time. These are the final assumption for us. Now in this case, we are studying about the position time equation. So from this graph, if you want to find the position will be what? Position will be nothing but the area enclosed within the graph. Area enclosed within the graph will be the position of the body. So we can write that S is equal to area enclosed within the graph. Area enclosed within the graph. Understand that? In order to find the position of the object, nothing, it's very easy. We'll find out the area enclosed within the graph. As you can clearly see, there are two structures has been formed within the graph. That is one triangle, that is ABD, and one rectangle, that is OADC. Can you see all this thing? That one triangle and one rectangle has already been formed within the graph, through which we can find out the position of the object. That means I can write that S is equal to area of the triangle, which triangle? Area of triangle ABD. Area of triangle ABD plus, if I add area of triangle ABD plus area of rectangle, which is the rectangle I was talking about, OADC. Area of rectangle OADC, remember. If we add this particular figure value, then I can find the position as well. Understand? So first of all, you should be clear which is the triangle. Triangle ABD, remember. Triangle ABD, we have to find the area of it. Then again rectangle OADC, we have to find the area of it. Then we have to add them and summarize the things. So S is equal to area of triangle. We know what is the area of triangle? Half into base into height. So in this case of triangle ABD, in triangle ABD, which is the base? Base is going to be AD. So half of AD into height. This is, so you can say as this is BD. Okay, half of AD into BD you can write. Clear? Plus, again you can write area of rectangle OADC. This is OADC. What is the area of rectangle? Length into breadth. So we can write in this case that AD into DC or AD into CD, we can take AD into CD we can take. Understand now? For this rectangle OADC, I can taking AD into CD. Like that, we'll able to find the required things for us. So S is equal to, this is half of, what is this AD? This AD is equal to what? Time t. So I can replace this AD by time t. So this is half of t. Clear? Next is your BD. This BD is a complicated thing, and BD we have to find separately the value of BD. So I am leaving this BD for time being. Plus AD. What is AD again? Again AD will become your t, time. Into CD. What is this CD? This CD will be your initial velocity u. This is, you can see CD. CD is going to be your u. So in this case, if I S is equal to what, this is half of T into BD plus this is your UT, we have arranged like it. Now your things will come, what is this BD? We have already find the value of BD in the previous diagram, but still I am telling you what is this BD. This BD is nothing but this BD is what? Change in velocity. That means we found that in the previous case, acceleration is equal to what? Change in velocity upon time. So in this case, if I write that change in velocity, in this case final velocity minus initial velocity. So final velocity is BC and initial velocity is your CD. So if I write here BC minus CD, I can write upon T. So we'll find that is equal to, once I subtract CD from BC, we'll find BD. So I can write BD by T. So the value of BD will give itself as AT. These things we derived in the previous diagram also. So I am putting the value of BD now. S is equal to half of T into BD. What is this? BD is AT plus UT. So S is equal to, now if I multiply, this is half of AT into T into AT, this is a half of AT square plus UT. That means I can arrange them now, or S is equal to UT plus half of AT square. This is our required kinematic equation that was needed to be proved, that is position time equation, that is S is equal to UT plus half of AT square. Have you understood it? It is nothing critical, but what is important for you, you need to more practice over it. These terms will also be important in the third equation when we prove in the next class. So please practice it, and if any doubt, you can ask me for about this, in which point you have doubt. Diagram is okay, no problem in this case, and these things are quite similar. Okay, in the next class we'll practice the next equation, that is last equation, very easy one. It is hot topic. For today, thank you.